Text engine in After Effects is a deep mine of jewels, but not many grasp its real potential. Only recently have I started to dig into it properly and still surprise myself with new ways of combining expression selectors with other After Effects elements to get results I never thought possible before. Some days ago, I was asked to build a template of a ruler-like timeline representing the distance between two non-consecutive years. I guess many of you have had to do it at least once along your career, only this time I opted for a procedural setup that allowed me to build many versions accurately and, more importantly, fast. Here's what the project looks like from the inside. Everything is done with just 2 layers of text. The points of a mask spline control the length and shape of the ruler. The first text layer generates the ruler itself with the correct number of subdivisions along the path, and the second one generates the numbers filling the ruler segment. All one has to do is change the start and end number of the segment together with the amount of subdivisions. As soon as you hit enter, the ruler updates subdivided correctly with all the filling numbers spread automatically along the path. You can change the subdivision number. I've set it to 12 for the number of months in a year, but you can use any number. The ruler doesn't have to be straight. You can give it any shape with as many points as you need, and it will update accordingly, respecting not only the position along the path, but the orientation as well. This way you can trace all sorts of travels on a map visualization. You can also modify it to quickly build any type of clock face or chronometer, and all of it using the power of Text Engine. Let me show you how I built it. Follow till the end. You might learn a new thing or two, trust me. Start with an empty text layer, name it ruler. Draw a mask path, straight at first. To turn this path into a ruler, we need to divide it using vertical lines. If you think of it, a vertical line is just a rectangle stretched horizontally. I'll use a special font to draw a perfect square into the screen. From the Fonts menu, choose Webdings. It's a free font that comes bundled with every Windows installation, just like Windings. Have a quick look at the character map and you can see that it comes packed with all sorts of symbols, ready to be used as character replacements. I'm interested in this one that draws a rectangle. What's so special about this particular one, you might ask? Any font can draw a rectangle if you type a dot. That might be true, but it depends on the font type. With Webdings, a small caps letter G draws a perfect square with all the sides equal to the amount of pixels you choose as the font size. Let's do a quick test to prove my claim. Add another text layer, name it bounding box. We'll use this one as a debugging tool to display the width and height dimensions of the square we just drew. Change the font back to some readable type. Give it a different color too. Go to the source text property and add an expression. Now type bb for bounding box equals thisComp.layer ruler dot sourceRect at time. This returns the bounding box of the layer we specified. To be precise, this is a JavaScript object which contains the most left plus top coordinates together with the width and height dimensions of the bounding box of the layer. Since the square is the only thing drawn in the ruler layer, it returns the dimensions of the square, exactly what we're interested in. To visualize these values, type bb.width plus comma in quotes plus bb.height. There it is. Now observe carefully how the font size in pixels matches both horizontal and vertical dimensions of the square. Change the font size several times if you're still not convinced. The same is true for the small caps N letter. It draws a perfect circle whose diameter matches the font scale. This is great because we can potentially use characters as shape layers, taking advantage of the text engine in After Effects. Let's continue. I'll leave the font scale to 100 pixel. This is important. It will make calculations easier later on. We'll control the scale of the character programmatically using the text engine's built-in animators combined with an expression selector. Animators allow you to modify several types of text properties. Clicking on the Animate menu displays a full list of those properties. Select Scale from the list. Rename this animator to Set Scale. Now, the scale of each character is calculated based on two factors: the maximum limit for all text elements and the selector range, which applies that maximum value in different amounts per character, word, or line. Get rid of the range selector and add an expression selector instead. This plays the same role as the other one, applying the overall scale limit to each text element in different percentage amounts, but is code-based, giving you more flexibility. Have it calculate the result based on characters. The percentage amount determines how much of the overall limit is applied to each character. The expression selector comes bundled with a default expression. Let's delete this code for the moment. We're working on a single character, so changing the amount value manually will suffice for what I'm about to demonstrate. Currently, the scale limit is set to 100%. 100% of 100 pixels is 100 pixels. So, whatever amount of that value we apply to the character, its scale remains unchanged. It's like multiplying with 1 all the time. Change the maximum scale to 200%. The cube bounding box is twice as large because 200% of 100 pixels is 200 pixels. Because we left the font scale to 100 pixels, we can now easily express the maximum scale for our rectangle as a percentage of 100 pixels. 200% means 200 pixels. Now, changing the expression selector amount reflects on the scale of the rectangle. With 100%, the overall scale is applied at full strength, so the character box size is 200 pixels. At -100%, the box size is 0 pixels. Remember, scale is represented as a percentage, so the square is still 100 pixels in dimensions, it's only scaled twice its size. 200% can also be written as 100% plus 100%. So, to scale back to 0, a square already scaled up by 100%, that means adding 100% to its original scale, you would need to scale the result down by -100%. To scale the square 10 times as much, you would have to add 1000% to the already 100% scale. To scale it down to 0 pixels, you would have to divide -100% by 10, that's -10%. 1000 has a 0 more than 100, so to scale down a square that is already scaled up by 1000%, we need to apply the scale -10%. Usually, I set the maximum scale amount to something way beyond what I need. Let's say 10,000%. A cool, round number, easy to remember, also a multiple of 100, our font scale. I then modify the expression selector value to convert each character scale into real pixels. Add 10,000 to 100 in the expression field. Store this value into a variable called percentage. Scale is a two-dimensional property, so for this expression to work properly, we need to return a two-dimensional array of the same value. Create an array, percentage, percentage. Set the amount value to -1%. This will scale the rectangle down completely to 0, I guess you see where I'm going with this. We can set the dimensions of our rectangle precisely to the pixel within the -1 to 100% boundaries. This represents a range up to 10,100 pixels. I highly doubt you would ever need a bigger square than this, but if you really do, simply increase the maximum value to 100,100. Then set the amount value to -1 divided by 10. Currently we have one character on the screen, so a single amount value is all it takes to modify its scale. To control all possible characters individually, we need to add an expression to the amount property. First, we need to read the maximum scaled up value. The straightforward method is to drag its property pickwhip to the scale property and let After Effects write down the global path to that property. It would work perfectly in this case, but I'll show you a better way to target other layer properties relative to the one you're working from. Using this method allows you to easily copy and paste this whole text animator onto another layer without any errors. Type this property dot propertyGroup in parentheses type 3 dot property scale in brackets 0. Save this value into a variable called maximum. Let me explain this line of code. This property returns a JavaScript object that represents the property we're working on. To test this, go down one line and type throw this property.name. It throws an error with the property's name on it. Now replace name with .propertyGroup and hit enter. The error that pops up returns the name of the group this property belongs to, expression selector. Inside the parentheses we can type how many times we need to repeat this command to get further up the properties hierarchy. By default this value is 1. 1 represents the immediate parent of the property we're working on. 2 goes up the hierarchy once more and returns the name of the group, selectors in our case. 3 will return the name of our animator, setScale. From here, we're targeting the scale property. This returns the maximum scaled up value. It's a vector with identical values on each coordinate, so either one will do. I chose the first element of the vector. Now delete the throw line. We need to set the pixel dimensions for our character separately and then map those pixel values into the percentage amount range. Let's start with this code. X pixels equals linear 10, 0, maximum, -1, 100. Let's say we want the squares to be 10 pixels in width. We're converting this value from the range 0 to the maximum amount possible into the range from -1 to 100%. Same thing for the other dimension. Copy-paste this line and replace X pixels with Y pixels. Also set the height to 250 pixels. Finally combine X pixels and Y pixels into a two-dimensional vector. Hit enter. Our square dimensions are now exactly 10 by 250 pixels. Try and change those values to test it yourselves. The numeric amount input values are now overwritten by the expression, so they play no role from now on. Everything is controlled by code. We're basically taking 100 by 100 pixel squares and scale them so they match precise dimensions in the range from 0 to 10,100 pixels. Now it's time to build a chain of these square characters going along the path we already drew. Expand the Path Options property group and choose our mask from the drop-down menu. Our square jumps onto the spline. Make sure to turn on the Force Alignment option so the square aligns to the direction of the path if it's curved. Add a marker to this layer, double-click on it. In the comments section, we'll create a JavaScript object that will store all our input data, start segment number, end number, together with the subdivision number. Let's start light. Type input equals open curly braces, S for start of the segment, colon 1, comma E for end of the segment, colon 6, comma SD for subdivision, colon 5, and close the curly braces. We will control the square count along the splines with these three values. Add an expression to the source text property. Let's read our controller values into our code. Type input equals eval marker.key1.comment. The eval function reads a string and evaluates it as JavaScript code, which means that the input variable now holds the JavaScript object we entered in the comment section of the first marker. We can access this object's element using the dot notation. Underneath, type g in quotes dot repeat math.absolute input.e minus input.s times input.sd. A literal g character in quotes repeat the absolute value of the difference of start from end multiplied by the number of subdivisions. Hit enter. You now see the curve populated with vertical lines equally distributed along the path. You might have also noticed that the start and end bars are not exactly on top of the start and end points of the curve. To take care of that, let's modify the first and last margin property values. Type -50 for the first and 50 for the last margin. Now the bars cover all the curve length. How did I come up with those numbers? Easy. Although we have scaled the characters, the font size is still 100 pixels and half of that is 50. You might have also noticed that the bars are not centered vertically on the spline. There are a couple of ways to do that. The easiest by far is to simply change the baseline shift value in the characters panel. By how much, you ask? You can eyeball it, or if you want to be precise, bear with me a couple more minutes and I'll show you. Turn off the source text expression, path options, together with the set scale animator. We're left with just one square character at the center of the screen again. Turn on the visibility of our bounding box layer. We'll work with the same expression on the source text property. The BB variable holds inside information for the topmost, left, width and height of our square. Because it is a text layer we're working with, everything is shown in the layer space. That means that the anchor point is in the 0, 0 coordinate. To visualize the top, bottom and middle vertical values, type bb.top plus, comma, in quotes, plus bb.top plus bb.height plus, comma, plus bb.top plus bb.height divided by 2. The top value returns the distance from the center of the topmost point. The bottom can be easily calculated by adding height to top and the vertical middle by adding height divided by 2 to the top value. Take note of these values. You might be tempted to enter one of them in the baseline shift property of the character panel. But the proper way to do it is to add another text animator, this time choose anchor point, and control the offset with it. Rename this animator to set anchor. Reset the baseline shift back to 0 and delete the range selector. You can enter one of the offset values directly into the second input, but the problem with that is that it only holds one value. It is better to have all three values stored into an expression and use whichever you need for your situation. Add an expression and type them in, each one in its own variable. In the end, generate an array, 0 as the x-coordinate and center as the vertical one. With the bar centered, you can get rid of the bounding box layer. Re-enable the expression for the source text on the ruler layer, path options, together with the set scale animator. A proper ruler has long bars for each full measure increment and shorter ones for the in-between subdivisions. Let's set them up now. Expand the set scale animator. We'll modify the amount property expression some more. Insert a new line after the maximum and type subdivisions equals eval marker.key1.comment.sd. This reads the number of subdivisions from the JavaScript object stored in our marker comment. Then type y equals text index -1 modulo subdivision question mark 25:100. What does this line mean? Keep in mind that the code in this expression runs repeatedly as many times as there are text elements. In this case, it runs per character. The percent character represents a modulo operation. I'm sure many of you know that modulo returns the remainder after a division. Each character is addressed by its index number. Each index after a modulo operation with the subdivision number returns either 0 if the number is fully divisible, or the remainder of the subdivision. In Boolean terms, this returns either false or true. If the division has a remainder, the value returned will be 25 pixels, otherwise it will be 100 pixels. In plain English, every full increment will be 100 pixels high, other subdivisions will be 25 pixels instead. Now set the y variable as the value to be normalized between -1 and 100%. Hit enter. See? A proper ruler. To generate the horizontal lines of the ruler, add a stroke effect to the layer. There is just one more tiny thing. The ruler ends with a short bar. To have it close the segment with a long line, expand the source text property and on the last line of the expression add 1 after the product of end minus start times subdivision. And there you have it. The ruler part is finished. You can stretch it, change direction. It will always behave as intended. It doesn't have to be straight. You can draw rounded curves also, with as many points as you wish. For the remainder of the video, I'll show you how to generate the numbers properly and have them positioned and oriented correctly along the curve. Add a new text layer called Numbers. Expand the source text property and add an expression. The numbers sequence will be dependent on the segment start and end values together with the number of subdivisions. So first, let's read those values. Type input equals eval thisComp.layer ruler.marker.key1.comment. Now create a new variable that holds an empty array. Type numbers equals open bracket, close bracket. This is where we'll store the numbers, one per line. Continue typing for I equals 0, I less than or equal math.absolute input end minus input start, I++. We're running a loop as long as the absolute difference between the start and the end of the ruler segment. Why the absolute difference? That's if for whatever reason you might want to enter a start value that is larger than the end, to always get a positive loop length. Inside the loop type, if input start is less than input end, number.push input start plus I. Else, numbers.push input start minus I. In case the start value is greater than the end, we want the sequence in decreasing order. Further down, type numbers.join \r in quotes. This generates a string with every value on its own line. Reverse the start and end values. You can see that our numbers start from the largest and end to the smallest value. How do we position each number along the spline? In the previous example, selecting a mask from the path options took care of positioning and orienting each square character along the mask curve. In this case, it wouldn't work for two reasons. First, the mask has to be on the same layer in order for the characters to follow it. Second, it's designed to spread each character along the spline, and here we're working with lines, but we'll manage it using text animators. Select Position from the menu, rename it to Set Position, delete the Range selector and replace it with, guess what? An Expression selector. Set it to work on lines. Again, the same principle applies. We set a maximum limit a text element can be offset and then moderate that amount per text element using the Expression selector. I'm using the composition's width and height as the maximum limit. It means that each text line can move at most one composition width amount of pixels to the left or the right, and one composition height amount to the top or bottom. We'll adjust this value in a bit, but let's start here. In the expressions field of the amount property, let's target the maximum limit value using a relative path, typing maximum equals this property dot property group 3 dot property position. Now let's read the mask path from the ruler layer. Mask path equals this comp dot layer ruler dot mask1 dot mask path. We can get a particular position along a mask spline using the pointOnPath function like this. Pause equals mask path dot pointOnPath. And in the parentheses we enter a 0 to 1 factor value that represents the travel amount along that path. We want to spread each line of the text along the path. Expression selector gives us access to the text index variable to address each line and also to the total number of lines. So instead of one value, we'll enter an expression here that will return a 0 to 1 factor for each line index. Remember, this code runs once for each text line. Type linear text index 1 to text total from 0 to 1. We're not finished. This expression returns an array of 2D vectors. But the expression selector property, the one we're working with, represents a percentage amount to apply the maximum limit for every line. We now have to express the position value as a percentage of the maximum limit. We'll use the linear function again, but because this function doesn't accept vector arguments, we have to use it separately for the x and y coordinates. Type x equals linear position 0 minus maximum 0, maximum 0, minus 100, 100. Copy and paste this line and make adjustments for the y coordinate. Replace position 0 with position 1. Also maximum 0 with maximum 1. and finally combine the result into a vector again. Open bracket, x, comma, y, close bracket. Hit enter. As you can see, the numbers spread okay horizontally along the spline, but each consecutive line pushes away vertically from the spline. That's because of the leading amount, that is the vertical offset amount for each line, and it's calculated before the expression. There are a couple of ways to deal with it. We could simply zero it out on the character panel. You can see the numbers jump into place. It is fine and good, but what I don't like about this particular approach is the fact that text becomes unrecognizable once you disable the text animator. The lines overlap, so you have to manually change the leading, edit the text, then zero it out again for the animator to work properly. I like to counter that using an offset amount in the expression. First, take leading into account in the maximum limit value for position, multiply the maximum vector by it. Type width height times text dot source text dot style dot leading. Then go to the expression selector, insert a new line under the position variable and type lead equals text dot source text dot style dot leading times text index -1. We're multiplying each line index number by the leading amount. Subtracting 1 makes sure that the first line doesn't move. Add this variable value to the negative maximum and maximum limit and hit enter. The expression now works no matter the leading value. At the moment, the numbers are placed right on top of the mask, overlapping the ruler division lines. To offset them, you might want to change the baseline shift value on the character panel. It works fine for straight line masks, but not for the curved ones. Try curving your path. You can see that now the numbers move straight up, but don't respect the curvature of the mask. Set the baseline shift value back to 0. We'll offset them in the expression also. Insert another line of text above the position variable. Similar to how pointOnPath returns the position vector along a mask line, normalOnPath returns the perpendicular direction vector for that point. Type norm for normal equals maskPath dot normalOnPath. Norm holds a vector that always points in the perpendicular direction to the line at a given factor. Inside the parentheses, map the line index number to a 0 to 1 range. Linear, text index, 1, text total from 0 to 1. Add that vector to the position vector. Not much changes visually because the normal is just a direction vector. It has a length of 1 pixel. Let's multiply it by a custom amount, let's say 100 pixels. The numbers jump below the mask line 100 pixels. If you want them above, simply multiply the normal vector by -100. Test it yourselves by modifying the mask path on the screen. You will see that the numbers not only stay attached to the spline, but their position also respects the curvature. There is only one exception though. If the line is straight, After Effects gets confused and doesn't know how to interpret the normal direction for the first and the last point. Straighten the line, move the endpoints around and see the numbers at the edge jump frantically above or below the mask line. To counter that, raise the lower limit slightly above 0, say 0.000001, and lower the maximum just below 1. That will do it. Now play with the curve handles and test the setup at your pleasure. Next, I will show you how to orient the numbers along the spline using the same technique, but this time using a rotation animator. Add a rotation animator, delete the range selector, Set the maximum rotation limit to 180 degrees. Why only 180 degrees? Because the expression selector applies this value in a range from -100 to 100% of that, resulting in a total of 360 degrees. Add an expression selector and set it based on lines. Again, reference the maximum limit by typing maximum equals this property dot propertyGroup 3 dot property rotation. Same as earlier, get the mask path equals this comp dot layer ruler dot mask 1 dot mask path. For each number, the rotation angle must match the direction of the mask path. Similar to the normalOnPath function, which returns the perpendicular direction vector to the mask path, the tangetOnPath function returns the direction vector along the curve. Type tangent equals mask path dot tangetOnPath. Inside the parentheses, instead of a single value varying from 0 to 1, we will write an expression that maps the text index number for each line to a range from 0 to 1. Same as earlier, to help After Effects avoid confusion in case of straight paths, we will set a lower limit slightly above 0 and an upper limit just below 1. The tangent variable holds a vector of 2 dimensions. What we need is an angle, a floating number. To convert a direction into an actual angle, we use a math function called arctangent. Type angle equals math.arctangent2. This function accepts 2 arguments, the vertical and horizontal coordinates of a vector. We will feed it the y and x coordinate of our tangent vector, tangent 1, tangent 0. By default, After Effects deals with angles in radians, but we want them expressed in degrees. So cut this expression and type radians to degrees and paste it inside the parentheses. Because this whole expression runs on every line, on every iteration, the angle variable holds the amount of rotation for each line. Let's normalize this value to express a percentage of the maximum angle limit. Type linear angle from negative maximum to maximum, from -100 to 100%. Hit enter. Observe the numbers rotate so they always target the mask line. Turn the set rotation animator on and off to see the difference. Play with the mask shape and test the setup with either curved or straight paths. I could have ended the tutorial here, but I told you that using this method lets you create all kinds of clock faces or chronometers. Until now we have worked with open paths. A clock is represented by a closed circle. Let's convert our mask to a circle. Open the mask shape window. Let's have the radius set to 400 pixels. Check the reset toggle and select ellipse from the shape menu. This generates an open circle. Right-click and set it to closed. You can immediately see the problem. The first and last points of the mask path overlap, and so do the first and last numbers. On the numbers layer, add the source text property expression, insert a new line at the top, and type closed equals this comp.layer ruler dot mask 1 dot mask path dot is closed. This line of code targets the mask path and checks whether it is closed or not. If it is, this variable will hold a value of true or 1. Otherwise, it will be 0. At the last line of the expression, add a literal return character and repeat it that many times. This will add an empty line to our numbers if the mask path is closed. Now the numbers are okay, but they don't match the segment number. Move to the ruler layer. Again, check if the mask shape is closed. Closed equals mask1 dot mask path dot is closed. Now add this value to the absolute difference of the start and end value. You can now toggle the mask status to open or closed, and the ruler will update just fine. Change the numbers to represent any range you need. If you don't want the numbers rotated, turn the set rotation animator off. If you feel that something's off, add an anchor point animator to adjust the vertical offset for each line. You don't need a selector for this one. All lines will have the same offset. Why use the anchor point animator? The anchor point represents the offset from the baseline of each text element. Have it centered on the numbers. Toggle the set rotation animator on and off to see the difference. And that is how you generate a fully procedural and accurate ruler using After Effects text engine and just 2 layers. I hope to have made every step clear so you can reuse some of these methods on your other projects. If you liked the video, consider buying the project files and support my efforts to create other videos like this on the channel. Also, don't hesitate to share the knowledge. See you soon.